Couple of key words that show up anytime we have proportion word problems are at this rate, as well as the word while. Both of these tend to tell you that we're doing two things at the same time or at the same rate as each other. Now, a key to setting these problems up correctly is to line up the units, because it's very easy to flip a fraction over when you don't intend to. For example, if you mean to say a over b is equal to c over d, sometimes you say a over b is equal to d over c accidentally. So watch how I line up the units as I work through these next problems. As we're working through this problem, we notice the phrase at this rate. That tells us we're dealing with a proportion problem. Now let's go through and reread this again. Pam drives her car for 243 miles on 4.5 gallons of gas. Those two pieces of information go together. So I'm going to write 243 miles over 4.5 gallons of gas that way. Now at this rate tells me to set up a proportion. How many gallons? Notice I'm missing X gallons down in the denominator are required to drive 621 miles. Notice how I have lined up the word miles up in the numerator and gallons in the denominator, and that they're not on a diagonal with each other. Now I'm going to ignore the units themselves, solve the proportion itself, and I'll find out that X is going to equal 11.5 gallons. And I wanted to focus on the setting up of this problem. You know how to solve it at this point by cross multiplication or by multiplying through by the least common denominator. This next problem does not use the words at this rate or while, but it does give you the word ratio. The ratio of men to women accountants in a large firm is 2 to 1. That basically means there are 2 men for every 1 woman. When you are given a ratio in a sentence like this, men to women in that order, 2 to 1, I'm lining up the first unit and the second unit with each other so that I know the 2 goes with the men and the 1 goes with the woman. Now this one's a little bit different. The total number of accountants is 81. Now we don't know if it's we know it's not 2 men and 1 woman. It could be 4 men and 2 women, or 6 and 3, etc. So I'm just going to say 2x plus 1x is equal to 81, and solve that to get 3x is equal to 81, and therefore x is equal to 27. Well, the 1x refers to the number of women, so we have 27 women in this problem, and 2x is equal to 54, referring to the number of men, and you'll note that if you add those two together, you do get 81. This geometry problem does not state that we're dealing with ratios, but similar triangles are triangles that are the same shape but not necessarily the same size. They're proportional to each other. So I'm going to notice that the 13 matches with the y, the x matches with the 18, and the 8 matches with the 12 when these are lined up with corresponding angles and sides. When I go to set my first equation up, I want to get one with x involved. So I'm going to say x matches with 18 in the same way that 8 matches with 12. Now notice what I did. I lined up my units. I said x, which is on the right side, matches with 18, which is on the right side. So both of these vertically represent the upper right side, and the 8 and the 12 both refer to the bases. Base from the first figure, base from the second figure. X was from the first figure, 18 was from the first figure. So everything pretty much is lined up without my actually writing the fact that they're lined up out for you. Now I can solve this by multiplying through by the least common denominator of 36, which cancels with the 18, leaving me with 2. So I'm going to have 2x, and the 36 will cancel with the 12, leaving me with 3 times that 8, which is 24. Therefore, x is going to equal 12. Now let's write an equation with y. Notice the 13 and the y line up with each other. So I'm going to say 13 from the left, y from the left, but from the first figure, second figure. Now I'm going to say, okay, let's go with 8 from the first and 12 from the second again. This time I'm going to multiply through by the least common multiple, which is 12y, least common multiple of the denominators, and this will give me 12 times 13, which is 156, is equal to 8y. And dividing by 8 on each side, I'm going to find out that I get 19.5 for the value of y. At the same time that a yardstick, at the same time, that tells us that we're going to have a proportion or two things that are kind of going on simultaneously. That a yardstick casts a 6-foot shadow. Well, let's think of a yardstick. Isn't that 3 feet casting a 6-foot shadow? Okay, that's kind of something we're given, and I'm going to assume that this yardstick is standing straight up. A tree is going to cast a 30-foot shadow, and we want to know how tall is the tree. What is its height? Now, I didn't do a very good job drawing this, but the reason we say at the same time is because the sun needs to be at one point in the sky in each of these problems so that we get shadows that are at the same angle, and you can see that I probably should have made this look a little bit more like that instead. But we can easily set up a proportion now and say, 3 matches with 6 in the same way that h matches with 30. 3 over 6 equals h over 30, and I think I would just notice, hey, I've got equivalent fractions if I just multiply by 5 down below and by 5 up above, and we will find out that the answer here is going to be h is equal to 15 feet. I'd like to, since we've got a little extra space here, throw in another problem. Let's say that we have a building here, and I'm not going to do a very good job drawing this building, and we have some man right here, and the building is casting a shadow, and the man is standing such that the tip of his head aligns with the tip of the shadow down here at the bottom over here on the bottom right corner. And we know that the man is standing 50 feet away from the building, and that his shadow itself is 10 feet long. Or we could just say that the whole shadow of the building is 60 feet long. And we'd have h right here, and we know the man is 6 feet tall. We can use this as another model to be able to discover the height of the building. But the trick here is that we would want to separate this into 2 separate triangles. One of them has an h with a 60 across the bottom, ignoring the man, so we add the 50 and the 10 together. The other one is the smaller one with 6 and 10 as the bases. Now you can just see in this problem very quickly that 10 times 6 is 60, so 6 times 6 is going to make 36, and the height of the building is going to be 36 feet in this case. But this idea or this pattern of lining up the tips of the shadows at the same time is another pattern we use when we're trying to find the height of a building.